Okay, and now for the last little part of our first podcast. And this one is addressing our second way of calculating our enthalpy, the law of summation. And this is just going to go over page 4. It's really not that bad of an idea. It's not as much of a puzzle as with that first way that we looked over with Hess's law. So, this way involves something called the standard enthalpies of formation. Now, remember, enthalpy is this delta H thing. So we've already talked about that before. But this standard enthalpy has this little circle up here to say we're in their standard state, meaning we're dealing with forming these elements and compounds the way they would naturally at room temperature. And then of formation is talking about that this is a measure of how much the energy is changing at standard state when we're forming 1 mole of this substance in its standard state from its components elements. So, how much energy does it take to make this thing from its building blocks, from its elements? Now, if you think about it, the standard enthalpy of formation for a pure element, meaning the amount of energy it takes to form a pure element from its component elements, is going to be 0, because it is its component elements. An element formed from elements, it takes no energy to make that. So, we're going to look at this table down below. There's actually 2 tables, but you're never going to see any elements in those tables because all of them are automatically 0. So that's probably the trickiest thing about these problems, is remembering when in doubt, it's probably 0 if you're not finding it in the table. Now, the law of summation of heats of formation is a little bit wordy, but we actually technically already saw this before. When it says that the enthalpy of a reaction is equal to the difference between the sums, so that's our summation, of the enthalpies of the products and the sum of the enthalpies of the reactants. This is that equation that we wrote down from our first part of this podcast, and I've added a couple of little details to it here, but it's basically just finding the energies of the products, subtracting them from the reactants. That idea of final minus initial is going to tell us how much it changes overall. Now, this added little details, these blue N and M's, represent the coefficients from the chemical equation, because this is the definition of that heats of formation. It's the formation of 1 mole of a substance. So, if more than 1 mole is involved in these reactions, we need to account for that. So, we're basically going to take the coefficient from the reaction and multiply it by these heats of formation numbers that have been measured that are in these tables, and add it together for the product side and the reactant side, and then subtract them. So, I know this might look complicated, but really I think if you stick with me, this process isn't that bad. The one thing to remember, because we're using those coefficients, the equation has to be balanced to give us those coefficients. So, this first example reaction that we've got is balanced for us, and we just actually saw this same reaction on the last page. It was the last example I worked out, but this one is being done at standard state, so this number might be a little bit different than the number that we got before. Just like I mentioned before, it's extra important here and now, so I'm just going to remind you that this side is our reactant side, and this side is our product side. So, I'll come back to that later, but that is going to be important. The process, like I said, is really just to find each of these substances in these tables. So, the first substance I see there is that NH3, and near the beginning of that first table, and this is the table with the better numbers in it, is our ammonia. So that's negative 46.19. And if we keep going, the our oxygen is going to be 0. It's an element, so don't have to worry about it. The NO is going to be right over here. And then our H2O is at near the bottom of that last table. And there's actually 2 H2Os here, so we do need to pay attention to the state of matter. This one was talking about gas, so we're going to be using the 241.8 number here. So, we find all our numbers, and I would normally be writing these down in the reaction. I'm basically going to replace NH3 with its number and leave that coefficient up front. So 4 times negative 46.19 plus 5 times 0, just reminding myself that that is 0. And that is my reactant side here. And then I'm going to look at my product side, 4 times NO, which was just 90, plus 6 H2Os, negative 241.8. Okay, so I'm basically taking all of this stuff and putting the numbers in instead of the substances. Now, I'm going to find the total for each of these sides, and it is important that we keep that division between the sides, and that once again we remember this is my reactant side and my product side. So if I go ahead and add up all of those numbers and do this multiplication and then add up, and this is adding 0, but here do this multiplication, then add it to this number. And my totals for my reactants was negative 184.76. My total for my products was negative 1090.8. Now, I'm not just adding everything up, because the law of summation, the final step, is actually a subtraction. If you don't remember, our delta H is equal to our products minus our reactants. So I found these totals, and I kept them labeled, so now I'm taking that products, negative 1090.8, minus my reactants, which was also a negative number. So it's important to remember here, you can do minus negative in your calculator and it can deal with it, but some of you I know don't have the same calculators that we would have. So if you're subtracting a negative, then that's the same as adding a positive number. So I just need to take this first negative number and add that positive number. And I'm basically running out of space here, but this equals 906.04 kilojoules of energy. So I think this way is a little bit easier. It's a lot of numbers still, but it's just follow the reaction. Make sure it's balanced. Find each of the substances in the table, write down those numbers, multiply them by the coefficients, and then you just have to remember to do products minus reactants. So that's it for our notes here. Now you can finish out the last little bit of page 6 from your assignment, your practice assignment in your packet. And hopefully this is a good quick end to this kind of longer podcast.